All right. Can you guys hear me fine? Okay, good. All right. Well, my name is Irvin Lopez. I'm from the University of El Paso, Texas, and we're here to talk about MINCER and how we're gonna work with OSG for that. Let's see. So our table of contents will be the project overview, our goals, our implementation approaches, and DCGM and LDMS and MINCER containers, essentially. Then we're gonna talk about a Docker swarm for deployment, and I'll show you guys a demo of how we did it. So essentially we have the project overview. So what is MINCER for you guys? MINCER is pretty much a containerized tools that will allow you guys to see in-depth, have in-depth insight and analysis for distributed heterogeneous computing environments. All right. So essentially, you guys get a lot of jobs in OSG. You guys get a lot of batch jobs and everything. What we want to see is what exactly is going on in those jobs. We don't necessarily need to see exactly what you guys are doing, but it would be cool to have like metrics on like how much CPU is being used, how much memory is being used, just kind of like have more information on your, whatever project you're running. Hopefully that'll help, better schedule things or manage resources more efficiently. So essentially what we want to do in conjunction with OSG is that we would provide MINCER containers for integration. Those MINCER containers will be equipped with all the tools that you guys need and essentially pretty much manuals on how to use them. So we want to make sure that we follow best practices to, ensure that it's up to OSG standards and it's pretty easy to use for all of you guys. What we do focus on is on GPU workflows and cluster-wide performance data collection. So it's mostly for GPUs, and just to make sure that we are able to monitor all information and gather some useful data for you guys. The next thing. So what are our goals for now? So here we created a lightweight container for LSDM, LDMS. And we are going to enable easy deployment and cleanup by monitoring containers across computer nodes, right? The way we do this is by aggregating monitoring data centrally and to avoid manually checking every node. So essentially what we do is that like we deploy all these, these Swarm containers and they're all centralized. So all the data is going through that central node and that is being managed by that central node. So you guys don't have to like manually be checking every single node for anything. And the same happens with cleanup. Like once everything's done, the centralized node will clean up everything and, just grab it, right? So our future goals will be to incorporate the DCGM for GPU specific metrics. So far, we do have the LDMS in it. It's just DCGM was a little bit complicated when it just wasn't really wanting to work out with the Docker containers. But yeah, and we want to contribute the final containers and usage examples to the OSG. That would be the final and ultimate goal of MINCER. So hopefully that'll be done pretty soon. So right here, I'm going to talk a little bit about LDMS in the MINCER containers. So a little overview for that is that it's just a low overhead metric collection tool. This plugin based architecture. So essentially you just kind of like grab a certain amount of plugins that you want to get information about. So essentially this will collect system level metrics like CPU, memory, and network usage, right? So how is this integrates with our work, right? We incorporated the LDMS into container image and configured it to seamless deployment in cluster environments, right? So essentially that's kind of where like the Swarm comes in. We made the image with the LDMS included in it, and once you hit that Docker Swarm, it'll propagate everywhere as much as needed. So again, we do not have the DCGM integration yet, but that is something very important that we're going to be working on. So here we have the implementation approach, which is where we speak about how we actually started using the Docker Swarm. So essentially, we built a container image with the LDMS and essential dependencies. Then we wrote a script that uses Swarm stack file for deployment of the LDMS container and to all nodes, right? With this, we ensure that the manager node aggregates the data for easier cluster-wide insights. So essentially, the manager node is the one that's going to be, swapping everything, changing everything for you guys, and keeping up with stuff. The modules we have used so far are bmstat and meminfo. A bit simple modules, but they'll prove useful in the long run. So the source code could be found in my colleague's GitHub, Ashken. And again, what we did not do is integrate the DCGM, and we have yet to export the LDMS and DCGM data into the OSG dashboard, but that's like pretty much the ultimate goal of the project. So I hope that works out fine. Next, we will have a demo pretty much by my colleague. He thought it was gonna be nice to make something like that. So, how do I play the video? Well, uh, I inserted, yeah, when before I submitted that. Oh wait, maybe you can click on like enable editing or something like that. Looks like a screenshot. Yeah, I'm not totally sure. When I put it in, before I put it in. Oh, there we go. Thank you. For sure, it'll just play it in there, right? The, oh, yeah. Maybe for this one, which was on one thing. Should we try to go back to the terminal? Yeah, let's try that. Yeah. That's good. Yeah, sorry about that. Maybe I should have downloaded the video. There
The head of the soul person really the idea here is that this repository allows me to quickly get vulnerability access to the suite of software with low overhead monitoring for compute nodes onto all of your compute nodes in your cluster and aggregate the data on a single node to make it easy for monitoring. There's many modules in LDS, but right now is including the MINCER and as a future goal, where we've had ECPM as well, or GP monitoring, but right now it's in CPM. Sorry, CPM. No. All right, and background. To actually deploy this, it's kind of pretty simple. So first off, let me environment, is deploying this back to back. Okay. And this is the command for QL. The stack fire and yes. Okay. All right, now we're going to please So if you're doing this for the first time, the first thing that you have to do is create a Docker swarm. So basically, this allows you to deploy containers on many machines in one command. And to do this, you do Docker swarm create on your aggregator node, and it tells you this. B is enforce errors. Okay. So once you see this message, the obvious error command here, and this is what we will paste on every single computer that you want to swarm. I'm going to go here. I'm going to do the Docker swarm first. We're going to paste the boom. Great. So now my home lab is doing this swarm. And to verify, I can do Docker node ls. And you can see we have two nodes, one is going to not this stuff with that, which is going to be acting on the basically anything that is not the machine where you're deploying the repository from is going to be treated like a problem. So you're going to have one aggregator, which is the current machine that you're deploying from, and everything else, swarm is going to be treated like a complete. So just keep that. All right, so now that the swarm is ready, the next step is very easy. You just do bash set up the sh. Obviously, the sh. And create the containers on all the machines. The aggregator will be an aggregator container, and the computer will be a sample. Once this is done, you're basically going to want to confirm that the containers are running, the Docker stack ls. You can see all the is currently active. And if you access the data that's being fed from a computer, you can go into the storage directory and just create a file batch as. Sorry, so there's only one folder for each module installed in LDS and CC1. But before we continue, you may get an error if you do this for the first, because since the process is really configured for Rana2, the anything that those create are technically owned by you. So you might have to enter it directly. The next step is we see storage and just do chmod -r from sudo as well. And then everything the password and see from names. Now we go to one of these directly, you can see a single file, which is in fact the CSV. It doesn't have the extension, but if we check it, you can see that it is in fact the CSV file. I notice that this file is always being appended to, and that's because the new data that the computers are sending back is constantly being appended to this file. So if you want to plug this in Python, you can, and since it is here, you can create it if you want to. Okay, that's pretty much it. If you have any questions, please feel free to contact me. You know, we on my profile. And thanks for watching.
All right. Well, that was a little bit of a live demo on how we're treating this. So essentially, this is good for monitoring. All the files are being saved as CSV. So hopefully that'll be easy for you guys to, play around with. So I believe wait, so to next slide. Yeah, there we go. So yeah, that is all for our MINCER project. We hope that it's very useful for you guys. We think that, being able to see what's going on with the jobs and, being able to identify certain, like bottlenecks or, overuse of resources or whatever is being underutilized, helps you guys, further improve whatever you guys are doing and working on. And we thank you. So this is our contact information, and the work is being supported by the NSF under the award 23, 46, 64, 23. So thank you guys.
Thanks. Hi, thanks for the talk. As someone who's, familiar with, say, Prometheus, hopefully you're a little familiar with it. Could you compare or contrast kind of what this system is versus what Prometheus does?
Well, actually, I don't think I've ever heard of Prometheus, but
Okay.
I mean, for example, as I said, the MINCER project is mostly focused on providing tools for you guys to be able to, essentially get metrics out of your work. And, we want to help, we want to integrate this with OSG to, precisely help them like see what's going on with their nodes, what resources are being used, how to see if they can, perhaps want to try allocate better, just to help out whoever's working on this to see information based on what they're doing.
Okay. Thank you.
Hey, thanks for the talk. I'm Brian Lynn from the CHGC Infrastructure Services lead. So you mentioned that this you want researchers to use this, and I saw you mentioned that you can build some of this LDMS stuff into containers. Are you is this for the glide-in jobs, or the glide-in containers, or for actual researchers doing science to also add to their containers?
So since it's a containerized tool, I believe that, it would be essentially all for the scientists, as you mentioned, and also for, certain batch jobs that you might be running, not necessarily just for scientists to kind of like look into. It's just, an overall tool that, can be used, pretty much in like any sense that you want to use it. So we just want to help you guys, be able to visualize what's going on with all that stuff. It's data is data, and it's usually pretty nice to know what's going on in your jobs.
Gotcha. Thank you.
You're welcome.